Astronomy Cast, episode 307 for Monday, May 20th, 2013, The Pacific Ring of Fire. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Doing well. So this is our kind of last reminder to people, although I guess when people get it in the feed, it's going to be too late. Yeah. We will have already done it.
Go back and look at everything on YouTube.
Yeah, go back and go back and look at all of the mad 24-hour CosmoQuest a-thon.
Yes.
What's the official name of this?
Hangout-a-thon.
Hangout-a-thon. There
yes.
You go. Where we, I guess at this point, did more than 24 hours of space hanging out. Well, not we, mostly you. And Nicole.
Noisy astronomer. Nicole.
And I only jumped in at occasional moments after being well rested and helped to entertain.
That's okay. You have children. You are never well rested.
That's true too. And so it starts on June 15th and 16th. And what's the exact time that it starts?
We are starting at noon Eastern, 9 Pacific, U.S. time zones, and going through until 8 p.m. Eastern, 5 p.m. Pacific on Sunday. So we're going from Saturday morning to Sunday evening. We're going to do a virtual star party on Saturday. We have Scott Sigler coming in to talk with Seth Shostak about the trope of aliens existing everywhere on human habitable worlds. We have Amy Roth coming on to talk about making space jewelry. We have the band The Jungle Fire, which does secular soul music, and I just love that concept. And so many others, too numerous to discuss here. All of this is going on YouTube on the Astrosphere Vids channel. Okay. So go check it out.
All right. And so check out the CosmoQuest page. I'm sure there's going to be more information there.
Yeah.
Awesome. Okay, let's go. So the Pacific Rim of Fire wraps around the Pacific Ocean, including countries like Japan, Canada, New Zealand, and Chile. And the inhabitants within those countries are prone to, killer earthquakes, volcanoes, and tsunamis. So let's chat about the history of this region and the kinds of risks they face. Now, Pamela, we always talk about how you live in the danger zone for tornadoes.
Yes.
Adorable, horrible tornadoes.
Yes.
As we've seen recently, there was, terrible tragedy in Oklahoma.
Yeah, Oklahoma was
horrible. So these are absolutely a big risk to humanity for the people living there. And yet, sort of on the same side, folks like me living on the west coast of Canada live in the Pacific Ring of Fire, and that's where I've got I've got volcanoes, I've got earthquakes, I've got tsunamis.
Yeah.
And as we've seen recently, the folks in New Zealand, the folks in Chile, the folks in Indonesia, there's a lot of really dangerous sort of stuff going on here.
Yeah, we have the rare extreme earthquake here because we have the San Madre Fault, which no one quite understands. It's like in the middle of a plate being confused. But the folks along the coast of North and South America on the western side, and then the folks all along the bands of island nations, so Indonesia, Philippines, all the way up then through Japan, across the Aleutian Islands, off of Siberia and Alaska, depending on which end you start. All of these people have the misfortune of being on the edge of the Pacific Plate, and this is a plate that is moving in unfortunate directions. It is pulling away from the Nazca line, which is a plate that's rubbing up against South America, and as it pulls away from the Nazca Plate, it is bashing itself wholeheartedly into the plate that Japan rests on, that Australia rests on, and at these points of collision, the plates are colliding, and you're ending up with welling up of magma, so you end up with lots of volcanoes in Japan. Mount Fuji is perhaps the most notorious example, although it doesn't do too much damage nowadays. But there's lots of active volcanoes there. You also have all sorts of active volcanoes all throughout the Indonesian islands and the Philippines. Krakatoa is a famous example. And this is, again, caused by the upwelling of magma. And as the plates collide, It's one of those things where it's like trying to move something along asphalt. It moves and then it'll get stuck with friction on the asphalt. You have to give it a good solid push to overcome that getting stuck, that friction. Well, when a giant continental plate becomes unstuck, it can have traumatic consequences, as was seen in Japan 2 years ago.
Yeah. Yeah. So let's kind of go into that then. So when you say that these plates can get stuck, what does that mean exactly?
So you have two different processes, three different processes really going on when you have a collision taking place. You can have subduction, which is where one plate goes under and the other plate goes over. And just like if you're trying to slide one piece of paper underneath another piece of paper, as you do that, you might end up with the one plate buckling instead of just politely sliding underneath due to frictional forces.
A quick note for the audio listeners: Pamela's making some really awesome hand gestures here to sort of show this. So, if you ever want, we always record these episodes live on Google Plus, and if you want to see Pamela's thrilling hand gestures, I highly recommend you watch it every Monday at noon Pacific, 3 Eastern. You can watch Pamela make hand gestures to go along with her astronomy. Please continue.
Yeah. Okay. Anyways, speaking. Right. Non-actual sign language at the camera. So as the one tries to go under, friction might cause it to get stuck and it buckles up at the edge. That buckling up is one thing, but then as it gets stuck, well, eventually all of that force building up behind it is going to give way to that plate moving. And it can sometimes move a few meters at a time. And when you're talking about a continent moving a few meters in a few minutes, that's a whole lot of energy that gets released. And it gets released in the form of sound waves. It gets released in the form of kinetic energy with the motion. And you can get everything from sharp jolting motions to slow rolling, rumbling motion. But either way, it's motion of things that has buildings and people or water on top of it.
And so I remember in the case of Japan, I mean, there was an earthquake and it was very bad, but the even worse part was this terrible tsunami that followed moments after.
The release of the energy into the water was what caused this terrific standing wave to start radiating away from the point of the epicenter of the earthquake. So the earthquake appeared to have occurred ways off the coast of Japan underneath the seafloor. And people are working to try and understand how do you predict which seafloor earthquakes are going to generate tsunamis and which aren't. And what they're finding is you can look at the energy that's released in the form of sound and measure that using horns dropped into the water to listen. And ones that produce tsunamis release vast amounts of sound wave energy. And that can be used to predict just how tall the tsunami heading towards land might be. So you have the energy released during, so it's all the potential energy, basically spring energy of the two plates trying to collide, getting released. During the release of that essentially spring energy, some of the energy gets converted into sound energy, and that sound energy predicts just how big the standing wave that is carrying the water with all the energy trapped in it towards land might be. One of the problems in Japan is their predictions for how tall the tsunami would be. It was predicted to be much shorter than it actually was, so people didn't seek high enough ground.
And I think, if you watch the videos of the tsunami coming in, I think, people kind of imagine this tsunami as this great big breaking wave that comes in and crashes in, but it really was this upswell. Like the water level just got deeper and deeper and deeper, and it just overflowed the banks, and then and material from the ocean was sort of being pushed inland, and cars were being inundated, and then buildings were being inundated. Like it's just this fast, relentless rise in water. It's quite terrifying, and you could see how once you realized that you were in the middle of this, you wouldn't see this wave off on the distance coming towards you and you flee to higher ground. It's just this rise in water all around you. Really scary.
The best demonstration you can do to try and wrap your head around what's going on with the tsunami is next time you change your sheets, when you go to put the flat sheet on, I'm assuming you're not using a duvet, being a Westerner here. grab the edge of that flat top sheet and just fluff it up with one quick jerk on the edge. And you'll have this wave that propagates through the sheet. And when it does this, the other side of the sheet has to come towards you in order for that wave to get formed out of something. Well, in this case, the tsunami is, instead of having someone's hands yank the edge of the sheet to put in the wave, it's the energy of the earthquake is that initial point for the formation of the wave. But the water that goes into this tsunami has to get drawn from somewhere. So when a tsunami is about to take place, all the water goes out from the shore, and suddenly you end up with significantly more beach than you would even during the lowest of low tides. And that's one of the early warning signs. And
don't go out and pick oysters.
No.
Run.
Yeah.
Right?
And so when you see the water going out, go up, go up, go up, go up.
Yeah.
And unfortunately, while they did get very early warning that a tsunami was coming, they didn't yet understand the role that measuring the sound had in predicting the height. They underestimated the height, and drowning was the leading cause of death. And it was just because people didn't get high enough.
But even so, I mean, that is a well-organized country, a well-organized response to the tsunami. I mean, the loss of life
could have been so much
worse, and we've seen so much worse in recent memory. We saw what happened in Indonesia. We saw what happened in Haiti. Exactly.
Yeah.
And so I think, I live on the Pacific Ring of Fire. I live on Vancouver Island, and this is actually, like, as you are well aware and made aware of the risks of tornadoes where you live.
Yeah.
We've got something very similar for earthquakes and tsunamis and stuff where I live. So, for example, our buildings are all done in a very special kind of code. That all of our houses have to be done in the special wood frame. If they're larger than that, they have to be done with steel and sort of in certain
floating
ways.
levels.
Yeah, exactly. And in Vancouver, there's a great building that actually has a pillar in the middle, and the whole building actually floats on these cables that hang from this pillar, and so the whole building can rock back and forth in an earthquake. The children are all trained and go through earthquake drills.
I remember that. I grew up in Southern California, and we had that in Southern California as well.
Yeah, and so they'll do that just like you'll do fire drills. Our kids will do earthquake drills.
Yeah, we do tornado drills.
And when you're out on the West Coast, when you actually go out to the coast, they mark out every spot which is at tsunami risk. So you'll be driving along, and then a sign will say, "You're now entering a tsunami zone," and there's sirens on all of the on poles and trees in the area, so that if you hear the sirens go off, and there's defined routes to get to higher ground in every one of these tsunami zones. And in fact, if you drive down the west coast of the United States, it's the same thing. You're like, now I'm in a tsunami zone, now I'm out. So then I think, how does the Ring of Fire manifest itself in different ways? Because, you mentioned that you've got the situation where the plates are coming together over in Japan, but here I know they're rubbing going sideways, right?
It depends on which plate is involved. And so along the Aleutian Islands, along the coast of Japan, you have plates that are mushing together. Then you have the Philippine plate, and they're still trying to figure out which direction it's going. That one, it's been harder to tell. We're colliding with the Australian plate. There's this rogue plate, the Nazca plate, that is between South America and the Pacific plate. And it's another one where it's colliding with the South American plate. That's part of what's creating the Andes Mountains. But then along the coast of where you are, there's again this extra floating plate, the San de Fuca. I don't know if I said that right. San de Fuca plate, and it's one that's kind of caught in the middle between the North American plate and the Pacific plate, and those two plates are moving in different directions, which is where California runs into all of its problems. That's those two plates colliding together, and there's points of weakness. So the San Andreas fault can be viewed as a point of weakness where these two plates are rubbing against each other, and the land is fracturing underneath.
Yeah, and I know that for us, it runs a couple of 100 kilometers off the coast of Vancouver Island, which I guess is a good thing and a bad thing.
That's actually the San de Fuca plate there.
Yeah. I think it's San de Fuca? Fuca. Um,
Okay.
but Right, and so you get the situation where, and we actually did have an earthquake, a very strong one, just north of here, just or south of an area called Haida Gwaii, sort of the Queen Charlotte Islands, and it was a very powerful one, but it was far enough away that I didn't feel it. But it was like, I think it was like 8, magnitude 8.
Wow.
Yeah, so it's quite enormous. So what causes this plate, and what causes this whole region to have
Well,
this? I mean, you talk about this
yeah.
plate, but why do we have one big plate like this? Why isn't it smaller? Why isn't it
It
bigger?
Well, so some of these things we can't easily answer. The best way to try and understand this is if you've ever tried to cook something that convects instead of boils. So oil convects, where you get this cells of hot oil rise and cells of cold oil sink. But you don't end up with the bursting bubbles. You don't have gas manifesting itself in oil. You just end up with this churning. You can, if you get your cherry filling just right, cherry filling will convect. Now, if you have a semi-solid floating on top of this convective surface, that motion underneath, that churning underneath, can lead to a fracturing of the semi-solid surface. In this case, we have a planet that is molten and convective in the layer beneath the crust. And our crust, just like that semi-solid surface on top of your convecting food, it ends up fragmenting, and those fragments get moved around by in this case, it's the combined inside the planet, everything's rotating, and so you end up with a certain amount of differential rotation. It's not a big deal with the Earth, but it does act to add to the motion. One of the things that I've seen questions raised about is part of the reason that Venus doesn't have plate tectonics the way we do, simply because it's not rotating sufficiently fast. Does that play a role? No one knows yet. We're still figuring these things out. But when we look at the biggest plates, there are actually arguments about, are we dividing the plates up enough? Can we divide them down farther? What really defines a plate? Because we do have fault lines. Like I live, as I said, near the San Madreas fault line, San Madre fault line rather, and I live right in the middle of the North American plate. But does that mean that really the North American plate is several smaller plates, or does it mean the plate I'm on is cracked and some of the pieces just move a little bit more readily than other pieces? This starts to get into fine-grained arguments of taxonomy. But overall, you have these large plates that the continents rest on that are moving apart. So for instance, right through the center of Iceland, which has a stripe of fire, you might say, that's where the two plates are pulling apart. Iceland's getting gradually larger and larger and larger as the plates pull apart. Volcanoes are all over Iceland, but the Ring of Fire is pretty much entirely where plates are colliding together. You have a mid-ocean trench with the Nazca Plate and the Pacific Plate, and as the plates collide together, you end up with, around the entire Pacific Rim, volcanoes and earthquakes. Now, the one confusing point is Hawaii. Hawaii is just this random set of hot spots people are still trying to figure out that sits smack in the middle of a plate. So Hawaii's not really part of the Ring of Fire.
Right. I mean, it's like a hot spot that could appear almost anywhere.
Yeah.
Right.
Yeah.
Although it is kind of right in the middle of the Ring of Fire. Coincidence?
Well,
yes.
I can't know. I can't speak to that. I mean, there's everything from people who think that the Hawaiian Islands are actually where something broke through the crust and left a weak point, and as the surface crust moves, there's a weakened hot spot. There's all sorts of things that don't entirely make sense that get put together to try and explain Hawaii. What we know for certain is as the plate moves, it's exposing new parts of crust to the hot spot underneath. And so you end up with a chain of islands as the crustal plate moves, exposing more to the hot spot.
And again, I think back to like say the United States. Have you ever done like I-5? Have you ever driven
Yeah,
I-5 from
yeah.
Canada down to California?
I've
And,
done LA to San Francisco, far less exciting, but yes.
yeah, right. So you're right. But if you do that there is a pretty much a volcano in sight for huge chunks of that drive. As you're driving south, there's Mount Baker, and then there's Mount Rainier, and then there's Mount Hood, and then there's Adams, and Mount Shasta, which is gigantic, and you see it for
Yeah.
hours and hours and hours. So you can really see that you've got these volcanoes just up and down the coast, and there's some stuff in Canada, not a lot, but then as you go down to like places like Costa Rica, there's some amazing volcanoes. Now, why do we get, like, if you're in Costa Rica, for example, there's ones that are in a constant state of eruption, ones that are like blobbing out lava nonstop. But in places like in the United States, you get places like Mount St. Helens, right, which build up for a
Um,
long time and then detonate. So why do you
it's
get that difference, even though it's sort of all the same plate?
Well, it's different chemistries and different types of volcanoes is one part. It's different geometries to the different volcanoes is a different role. The rate of magma production plays a role into this. So if you have one that it's more active in creating the magma, or rather there's a larger channel that allows the magma in, it's going to grow much more quickly. So there was a case in Mexico, I believe in the 50s, of a farmer's field that got a hot spot that a few years later was a giant volcano, and then it pretty much stopped.
Right. Yeah, I remember that story. It was like
Yeah.
we had that as like a book, like it was a kid's book. I
Yeah,
remember
you
reading
and I have
this.
talked about that. Yeah.
Yeah,
And I always wanted the farmer's field behind our house to grow a volcano.
me too.
I was a
That would have been
stupid
so
small
cool.
child. Yeah, but
Yeah.
it would have ruined our
Oh,
house.
but it would have
But
been
I was a
awesome.
child.
Yeah.
Yes, it would have been awesome.
Yeah.
Um, so all around the Ring of Fire, it's a matter of how the plates are colliding. What's kind of neat is you don't always, when you have the plates colliding, end up with ringovolcanoes. So where you look at the India plate hitting the Eurasia plate, you have the Himalayan mountains, and Mount Everest is not a volcano. It's just a giant, insert expletives, mountain.
Hmm.
Because in this case, you have two plates coming together and ridging upwards. And it's where they come together and ridge upwards. You don't get the same volcanism, but you do get giant mountains. And kudos to the giant mountains.
So now living here on in the Ring of Fire,
Yes.
uh, you know, I think we don't get the same kind of constant in your face fear of it. I think that you do, for example, with the tornadoes. Like, you experience a certain amount of tornado fear, and rightly so. I mean, what happened a couple of weeks ago with you
Yeah.
having a tornado pass right through. I mean, we get occasional earthquakes. How dangerous is this for me to live here?
It's one of those types of statistics that is hard for a human to wrap their brain around. So, for instance, when you look at 1 in however many thousand people will die by airplane, that doesn't mean that each individual has that kind of probability. You need to instead look at how many 747s fall out of the sky, and the probability comes from the fact that a 747 carries a shed load of people on it. One tornado generally won't kill a lot of people. One earthquake will kill a lot of people. So what you need to consider isn't what is the probability of an individual getting killed by an earthquake, but what is the probability of where I am getting violently shaken by an earthquake. And places where you are, it looks like it's probably every 100 years to every couple hundred years there's a devastating earthquake. But we're still trying to understand those things better. Some plates are moving more than others. That's why China keeps having so many issues.
Yeah, I know, and I know that there are some examples of some pretty bad, as you look at the archaeologists, as they look back in time and look at these, different sites.
Yeah.
We had a situation a couple of 100 years ago. We had pyroclastic flows, which wiped out villages.
Yeah.
I think it was of the Niska tribe. in my area.
Yeah, and in our area, we did see the city of St. Louis, when it was first getting founded, got completely flattened by an earthquake that actually changed the flow of the Mississippi River.
Yeah.
So it's when you consider that the largest river in the United States had its path changed, moved, and temporarily reversed direction because of an earthquake, that gives you a sense of how much power they can have.
Big chunks of Seattle are built on the pyroclastic flows from Mount Rainier.
And when you start thinking that Mount Rainier isn't dormant, it's simply paused. Mm-hmm. And we don't know when it will unpause, and there's a huge population around it. That's a little bit unsettling, to say the least.
Yeah,
absolutely. If you ever want to have a very fast, comparatively, view of vast numbers of volcanoes, and you have lots of money to burn or vacation, the flight from Beijing to Seattle goes up and over the Aleutian Islands and back down along the coast of Canada. And I remember waking up at one point on that flight and then couldn't stop looking out the window, because it was snow-capped volcano after snow-capped volcano. Right. And you can occasionally see some of the Alaskan ones smoking out in the distance. And
right, you've got all those ones up the coast of Russia.
Yeah.
You know, and then all the ones along the Aleutian Islands, and then that'll just be amazing.
Yeah, so that's one way to get a great view of them is to take that morning flight out of Beijing and land in the afternoon in Seattle.
Right. Now, what impact did sort of the large movement of the continents have on the Ring of Fire? Like, hundreds of millions of years ago, we had Pangaea, and I guess in the far future, we're going to have a different situation. Is this making the Ring of Fire larger or smaller?
One of the things we're still trying to get a handle on is how is it that the plates rotate the way they do. We know that a new plate is basically going to come into existence. Plate may be too strong of a word. We know that a new continent is going to slowly grow into existence where Iceland is. Baby, tiny.
Right. I mean, I guess, in Pangaea time, right, you had South America crunched into Africa. And so, that whole area, that ocean is brand new,
and
right?
The Saudi Arabian Peninsula is breaking off of the Arabian plate, off of Africa. And so this is just all part of all the continents are in constant motion. And there are predictions about what the different configurations would be. We know that there is a sea that's going to open up between Saudi Arabia and Africa. And it's just kind of amazing to think of Ethiopia becoming, growing an ocean, kind of like the Mediterranean inside of it. But that's the future that we're looking at. Everything's in motion, and we just need to wait the billion years or so to see where it all goes.
Right. So I think, based on this conversation, I will probably be killed by any manner of terrible
I would
catastrophe.
Not say that.
The universe is trying to kill me.
The universe is trying to kill you, but I think genetics and old age are much more of a fear. No, I think if you're going to walk away with anything, it's colliding plates that are subducting like to breed volcanoes. They're pretty. Stay away from them. If you happen to live in that zone, know how to go up quickly.
Yes.
And if you want the Himalayas, just crash 2 plates in and let their ends fork up together.
All right, cool. Well, thank you very much, Pamela.
Thank you.
Okay, don't go anywhere.
Ding. Saving. Quitting GarageBand.
I would love to go down and see the Costa Rica volcanoes. I've actually never seen like an erupting volcano. Like I've been to the Big Island of Hawaii.
In January.
I know. I haven't actually seen it blobbing out lava. I'd love to see that. Okay. Exported. Done. Okay.
Okay.
Awesome.
Cool.
And I'll start the upload. And my daughter came in 3 times to ask me questions. I don't know if you noticed.
Yeah, I saw the look of kill child. We love your daughter, but look, it's better this. You're only a year away from a teenager who doesn't want to speak to you, so enjoy it.
Oh, that'd be sweet. I can't wait. Okay. All right, cool. And then, so if you've got any questions, I know we can't stick around too long, but we can take a few quick questions. One here, let's see. Kevin Franklin says, how awesome is Pamela's microphone? Step up, Fraser Cain. I have stepped up. I have an awesome microphone too.
Yeah, that's the baby sibling to the one I've got.
That's true. Yours is a USB as well, right?
No, mine. I have a. I have the Icicle.
You have an Icicle and then plugged into USB?
Yeah.
This has got to just sound horrible now. I'm sorry. Okay. Well, it's not going to work now. All right. I've got the Blue Snowball, and it's a nice condenser mic that goes into the USB, and it is. Yeah. I'm so happy with it.
His is just hidden underneath his lower third.
Yeah, but it's a pretty beefy condenser mic, so you just can't see it. It's just all built in.
Yeah, I'm having geometry issues, but that's a personal problem.
Icarus Factor notes that plate tectonics is a new field of science from the mid 1900s. You would have thought it older than that. That's absolutely. I mean, 1950s was like the first proposals on plate tectonics, and there's a great story. I think Dawkins tells this story about how scientists will admit when they're wrong, and I think it was that one that some preeminent scientist had, and I could be mushing this all up, but some preeminent scientist had been sort of against plate tectonics or a theory like that, and then when he had presented with enough evidence, he just walked over, shook the hand of the scientist, and said, you got me, I was wrong. Yeah. You're right, I'm wrong. The overwhelming evidence has convinced. I know has convinced me, and I think we've talked about this a bit in some of the early episodes about the scientific method and things like that, just how scientists, ideally a scientist won't have any ego invested into their theory and their observations and so on.
Yeah, right? But we're humans, and so we still get our
exactly. Yeah. But ideally, you just want to have what's right, what's correct, make it out, and if you're proven wrong, but I mean. The fact is that can you imagine the journal? Is there a journal like this, the Journal of Negative Results?
There's different websites that different people in the open access community have been working to put together, but that's actually a fundamental problem because it's one that actually I ran into with my dissertation because I discovered a perfectly good way to find find galaxy clusters using radio sources that required many times more work to gain 1%, 2% more chance of finding a galaxy cluster than just kind of pointing your telescope at any old radio source. So that wasn't really publishable. It was you did what?
Yeah. Right. So, something to the effect of, we looked at 1,000 clusters and we didn't find anything.
Well, so in our case, it was instead of looking at individual radio sources to see if they happened, that when you see a radio source on the sky, it's most likely going to be a galaxy. Most galaxies are in clusters. So when you look at a radio galaxy, you have a 20-something% chance of finding a galaxy cluster around it. And so we got the neat idea that if you looked at a cluster of radio sources, you could increase the probability of finding a galaxy cluster. And no, what we were actually finding was lots of galaxies strung out at all different distances along the large-scale structure.
And it was just too hard to kind of tease out which was which.
Well, no, we could tease out which was which just fine. That's what spectra are for. But the problem was when we looked, what we were hoping is all these objects that turned out to be line of sight would all be grouped together gravitationally, and they weren't.
Yeah.
And that's a non-interesting result.
John Hrubesh says, can super-Earth planets that are twice as large as Earth have plates, or would a planet that size have a thick crust like Mars? So first, I think the super-Earth planets that people are talking about, I mean, can they be twice as big as Earth?
It depends on, I hate words like big and small.
Can they have twice the radius of Earth?
You should be able to have twice the radius of Earth. It will have many times more mass then. So depending on what the combination of density is based on what it's made
Right.
of, what the metals are, things like that, how much volatile it's managed to capture. Um, yeah, there's no reason you couldn't have plate tectonics. It's just a matter of do they work like they do on Earth. Don't know. It depends on the thermodynamics of the system.
Right. Um,
Heck, you can have plate tectonics on small things as well. It's just they work differently.
yeah.
And you can end up with ice plate tectonics if you look at Europa.
Yeah. Dex Luther asks, we mentioned the 20-hour fundraiser. If people don't have cash, but they do have time, is there something they can do? Yeah, just help get the word out.
Yes, yes. Also, beyond helping to get the word out, tune into our Hangout-a-thon because we're going to be doing everything we can to teach you, and we're going to be working to engage you in things like coming up with a Cards Against Astronomy game. We're going to do some captioning contests. We're trying to build community as well. So you never know what warm body you're going to bring in is going to bring the next great discovery to CosmoQuest.
Michael Jobin suggests sound effects for your hand gestures.
I need to have a theremin.
Yeah.
Play theremin as I just...
Yeah, exactly. Crazy sounds. Let's see. Okay, good. I think that's all the questions I've got. Kevin Franklin recommends the Annals of Improbable Research, which is
that one's
fantastic.
Fun.
Yeah. But that's more like just weird stuff that people, researched, as opposed to, we researched this mundane thing and we got no result.
Or we researched this thing that we thought was going to be very exciting,
and it
wasn't, which was my research.
Right. Cool. Okay. I think that's all the questions we've got. So let's wrap it up because I know you've got tons of preparation to do, and I have children to have a conversation with about Daddy's recording Astronomy cast. So cool. All right. Well, thank you very much, Pamela. Thanks everyone for watching. So I guess the next big thing we're going to do the Space Hangout on Friday.
Yes.
Okay.
The weekly Space Hangout on Friday.
Yep.
And then let the Hangout-a-thon begin.
On
9 a.m.
Saturday.
Pacific, noon Eastern.
I look forward to your on-air mental breakdown. For science.
You have no idea how many episodes we've recorded after I've pulled all-nighters programming. You don't notice these things.
I can tell. No, I can tell. No. Awesome. Okay, well, thank you again, Pamela. Thanks, everyone, for watching.
Okay.
We will see you all next time.
Okay, bye-bye. It's moving in unfortunate directions. It is pulling away from the Nazca line, which is a plate that's rubbing up against South America, and as it pulls away from the Nazca plate, it is bashing itself wholeheartedly into the plate that Japan rests on, that Australia rests on, and at these points of collision, the plates are colliding, and you're ending up with welling up of magma, so you end up with lots of volcanoes in Japan. Mount Fuji is perhaps the most notorious example, although it doesn't do too much damage nowadays. But there's lots of active volcanoes there. You also have all sorts of active volcanoes all throughout the Indonesian islands and the Philippines. Krakatoa is a famous example. And this is, again, caused by the upwelling.
I've got volcanoes, I've got earthquakes, I've got tsunamis.
Yeah.
And as we've seen recently, the folks in New Zealand, the folks in Chile, the folks in Indonesia, there's a lot of really dangerous sort of stuff going on here.
Yeah, we have the rare extreme earthquake here because we have the San Madre Fault, which no one quite understands. It's like in the middle of a plate being confused. But the folks along the coast of North and South America on the western side, and then the folks all along the bands of island nations, so Indonesia, Philippines, all the way up then through Japan, across the Aleutian Islands, off of Siberia and Alaska, depending on which end you start. All of these people have the misfortune of being on the edge of the Pacific plate. And this is a plate that is here. All of this is going on YouTube on the Astrosphere Vids channel.
Okay.
So go check it out.
All right. And yeah, so check out the CosmoQuest page. I'm sure there's going to be more information there.
Yeah.
Awesome. Okay, let's go. So the Pacific Rim of Fire wraps around the Pacific Ocean, including countries like Japan, Canada, New Zealand, and Chile. And the inhabitants within those countries are prone to, killer earthquakes, volcanoes, and tsunamis. So let's chat about the history of this region and the kinds of risks they face. Now, Pamela, we always talk about how you live in the danger zone for tornadoes.
Yes.
Adorable, horrible tornadoes.
Yes.
That can, as we've seen recently, there was, terrible tragedy in Oklahoma.
Yeah,
so,
Oklahoma was
so
horrible.
these are absolutely a big risk to humanity for the people living there. And yet, sort of on the same side, folks like me living on the west coast of Canada live in the Pacific Ring of Fire. And that's where I've got Astronomy Cast, episode 307 for Monday, May 20th, 2013, the Pacific Ring of Fire. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Doing well. So this is our kind of last reminder to people, although I guess when people get it in the feed, it's going to be too late.
Yeah.
We will have already done it.
Go back and look at everything on YouTube.
Yeah, go back and go back and look at all of the mad 24-hour CosmoQuest a-thon.
Yes.
What's the official name of this?
Hangout-a-thon.
Hangout-a-thon. There
Yes.
you go. Where we, I guess at this point, did more than 24 hours of space hanging out. Well, not we, mostly you. And Nicole.
Noisy astronomer. Nicole
And I only jumped in at occasional moments after being well rested and helped to entertain.
That's okay. You have children. You are never well rested.
That's true too. And so it starts on June 15th and 16th. And what's the exact time that it starts?
We are starting at noon Eastern, 9 Pacific, U.S. time zones, and going through until 8 p.m. Eastern, 5 p.m. Pacific on Sunday. So we're going from Saturday morning to Sunday evening. We're going to do a virtual star party on Saturday. We have Scott Sigler coming in to talk with Seth Shostak about the trope of aliens existing everywhere on human habitable worlds. We have Amy Roth coming on to talk about making space jewelry. We have the band The Jungle Fire, which does secular soul music, and I just love that concept. And so many others, too numerous to discuss.